All right. When we say properties of math, of real numbers, the properties are what we can do, about what we can do and how we can do it. We have order of operations of when we're supposed to do it. Now this tells us what we're supposed to do and how we're supposed to do it. So the first property is the commutative property of addition. What do you think? What do you think commute means? This one is a commutative property. So what do you think commute means? That will be connected. When you commute, what are you doing? You take a bus. That's a form of it's a commuter system. What the commutative property does, it tells us about what we can do when we move numbers. To commute means to move. What this one says is two numbers, any real numbers, x plus y, is the same thing as y plus x. Three plus 4 is the same thing as 4 plus 3. They both equal 7. That's the commutative property. If I can move the numbers around, it doesn't make any difference. But this is for addition. That's the first property. The second property is the associative property of addition. The word associate or association means you're forming a group, you're grouping things. For example, if I had three terms, X, Y, and Z, that equals X, Y, and Z. But the problem is this: nothing in our known universe can process more than 2 bits of information at any one time. If I gave you 3 numbers, 3 plus 4 plus 5, yes, we know that equals 3 plus 4 plus 5. But how would you do it? If I gave you 3 numbers, what would you do first? 3 plus 4, and then that, yeah. Because the human mind, the fast computers cannot do more than 2 bits of information at any one time. Hence binary. So what we're doing here with the associative group is we have to tell what 2 numbers do you combine first. Since they're all addition, it doesn't matter which numbers we combine first. Go ahead and read your text message for us. Read your text message. Read it out. Read it out. It sounds interesting. What's that? That was from your broker? What system are you using? Oh, okay, then that's obviously more important than this. Put your phone away. If it picks up again, we're having a quiz. So what this thing says is, remember, in order of operations, parentheses tell us what to do first. So here, 3 plus 4 is 7. Then we do 7 plus 5 is what?
1.
As opposed to the other side. Now, the other side says we do 4 plus 5. 4 plus 5 is 9 plus 3. You could combine them any way you want to make it easier for you. That's the beauty of this property. The third property is probably the most important one, is the distributive property. The distributive property combines multiplication and addition. What this property says it's a property that gets rid of parentheses. What is the number in front called? What is the number in front of parentheses? What is that called? Starts with a C.
Coefficient.
Coefficient. Very good. That's a coefficient. How is the coefficient connected to the parenthesis? What operation is it holding? But remember, if there's nothing between there, it's multiplication. Everything else has to have a symbol there. Subtraction has to have a little minus sign. Addition has to have that plus. Division has to have that slash or the line with 2 dots. Multiplication is the only one that doesn't have to be there to be there. So this is A times this. For example, remember order of operations. Can you do inside the parentheses? You can. What is 5 plus X?
6.
You can't do anything inside parentheses. So our next purpose is we have to get rid of the parentheses. This is where distributive comes in. Whatever's in front, since it's multiplication, multiplies to everything inside there. Remember, keep the signs and numbers different. Positive times positive is a positive. 3 times X is 3X. Positive times positive is positive. 3 times 5, 15. So what the distributive property does, it gets rid of parentheses. It allows us to take it to the next level now. Remember, the whole purpose we're trying to get to is so we can solve for equations. Let's test this theory. We'll do it both ways. One way we'll use the order of operations. The other way we're going to use the distributive property. So go ahead and use the distributive property. What does that become over here? What did you do first? 3 times 4, okay. And there's a plus, then we do 3 times 5. That's distributive property. So, okay, so what do we have 3 times 4 is 3 times 5, 12 plus 15. Now let's look at the other way. If we did order of operations, we have to do inside the parentheses 4. First, 4 plus 5 is 9 times 3. So it works. That's the proof of it. Now, the distributive property is probably the most powerful tool you're going to learn so far in mathematics. It has 2 different names. So AX times plus AY. Going this way from left to right, it's distributivity. We're distributing. We're going from left to right. We can also go the other way. This is called factoring. That's what we're going to be using the second half of the course. Yes.
So back to 3x plus 15, so you can't do anything since that's the final answer?
No, that's not the final answer. It's just we can't do anything inside there, so we have to get rid of the parentheses. If you can't do anything inside the parentheses, you have to get rid of the parentheses, which is why we use distributivity.
Like, talking about that answer, 3x plus.
This is as far as you can go. That's as far as you can go.
Because you can't do anything since it's 3x.
Right. X is a variable. It can be any number you want it to. Once you define what X is, then you can have a value. But until then, this is as far as you can go until X is defined. So going from this side to this side, what do they both have in common? What do AX plus AY have in common? It's not a trick question. Just what do you see there? What do they have in, what's the same in both of these equations? They both have an A. So write it down. So that since they have that in common, everything else goes inside the parentheses. They both have an A in common, so I take that out. I put it there. What do I have left? X plus Y. The distributive property goes both directions. Okay, the next property. Identity property of addition. X plus what number gives me X? Let's X keep its identity. When you add something, X plus what gives me X? Or maybe a number. 3 plus what number gives me 3? Very good. 0 is the additive identity. Because if you add 0 to any number, it keeps its identity. It keeps its same value. So X plus 0 equals X. And the inverse property. Of addition. X plus what gives me 0? We know X plus 0 gives me X. So it can't be 0. 3 plus what number gives me 0? -3. So X plus the negative of X, the opposite of it. When you say opposite, we're talking about the negative of the number.
Is that what inverse is? Is the
Mhm. The additive inverse is the opposite. So the opposite of 5 is -5. The opposite of -7, 7. And the reason we do this, because when we start solving for equations, this is how we get rid of numbers that are added and subtracted together. And the last one is called the closure property of addition. The closure property says this: let X and Y be natural numbers. First off, what's a natural number?
zero?
We talked about this earlier. We're building up our number system. We have natural numbers. We have whole numbers. We have integers. We have real numbers. Natural numbers are our counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Left into infinity. Whole numbers starts with a whole. Starts with 0. Then it goes to 1, 2, 3, 4, 5, 6, 7, 8. Integers have positives, negatives, and 0. And real numbers have everything else. Fractions, decimals. So let X and Y be natural numbers. They're counting numbers. The rule of addition, the closure property of addition says if I take X and Y and add them together, they're going to equal another number. A unique natural number. In other words, since X and Y are natural numbers and I add them together, the answer is a natural number. That's closure. It's closed under the natural numbers. It gets complicated once we start talking about division, because we can't divide by 0, but everything else works. So these are the properties of addition. Any problems so far? Okay, let me All right, work these out. Let's work these out. A, small a, what does it match to? Identity element for addition. B, 0, very good. Anything plus 0 is itself, keeps its identity. Okay, B, identity element for multiplication. What do you multiply by to keep its own identity? Three times what equals 3? 1. So 1 is the multiplication identity element. C, the additive inverse of A. Negative A. Additive inverse means opposite, so it means negative of a number. The multiplicative inverse or reciprocal of A. What do you think? What does reciprocal mean? You've heard it before. 1 over A. Very good. Very good. Because remember, the inverse gets rid of the number. The inverse of 3 is -3, because if I add them together, they cancel out. So 3 times what? What cancels 3? 1 over 3. So the reciprocal is the reciprocal, the flip of it. A number that is its own additive inverse. The number that is its own additive inverse. What does the inverse do? -1 plus -1 is not 0. The number that is its own, because it's the number that is its own additive inverse. What number, when you add the negative of it, becomes 0? Oh, no. The answer is 0. Because 0 has no sign. 0 plus anything, if it's 0 plus itself or 0 minus itself, it's still going to be 0. So the number that is its own additive inverse is 0. The two numbers that are their own multiplicative inverses. The two numbers that are their own multiplicative inverses. What does an inverse do? We've said this a couple of times. What is an inverse?
The opposite.
The opposite. In other words, it gets rid of it. Multiplicative means multiplied. So what two numbers are their own multiplicative inverses? 1 and -1. 1 divided by 1 cancels. -1 times 1 over -1 times -1 cancels out. So those are their own multiplicative inverses. The only number that has no multiplicative inverse . Which number does not have its own reciprocal? What's the only number they cannot divide by? What's that? 0. Very good. 0 is a number. It doesn't have a multiplicative reciprocal. So 0 is the only one that does not have a multiplicative inverse. An example of the associative property.
Okay.
Very good. A is an example because what is the associative property? Its only thing changes is the parentheses. The numbers stay in the same order. You don't move the numbers, you only move the parentheses. An example of the commutative property. G, yeah, because that one moves. And distributive property? H, because you're getting rid of the parenthesis. If you look at an example and you get rid of the parentheses, that's the distributive property. So basically, yeah, the important words are commutative, distributive, associative, inverse. It doesn't matter if it's additive or multiplicative. Let's look at those now. Properties of multiplication. What's that? No, it's number 1. Because this is the total property now. Because first time we talk about the properties of addition, now these are the properties of multiplication. The commutative property of multiplication. X times Y is the same thing as Y times X. In other words, 3 times 4 is the same thing as 4 times 3. There's commutativity, means to move. I can move the numbers around. The associative property of multiplication. X times Y times Z is equal to X times Y times Z. Remember, the associative deals with grouping. You form groups. So we combine the first two and last two. It'll give you the same answer. This is a better example of the importance, the power of using this property. Three times 4 times 5. Work these out and tell me which side's easier. Let's do the left side. Inside the parentheses first. 3 times 4 is 12. 12 times 5. How'd you get 60? What'd you have to do first? 5 times 2 is 10. Carry the 1. 5 times 1 plus more movement. How about the other side? 4 times 5 is 3 times 2 is 6 with a 0 behind it. This by far is much easier. Less chance of mistake because this one here, you have to carry the 1, remember to add it, and that's where most mistakes happen. So by far, this shows you the power of it is that you can pick whatever numbers you want to combine. Using the commutative property, you can move the numbers, the equations of the equation around as long as they're all multiplication. Whatever makes it easier for you. We discussed the distributive property. That's the same in both addition and multiplication, so we're not going to worry about that. Oop, I want 3. Identity property of multiplication. X times what gives me X? Or 5 times what number gives me 5? 1. Anything times 1, you keep the identity of that number. It doesn't change. The multiplicative inverse property, or the inverse property of multiplication. What times X gives you 1? 5 times what gives me 1?
Negative.
1 times -1 is -1. So it's not 1. What times 5 gives me 1? In other words, what cancels 5? Right? So where does the 5 have to go for it to cancel? Has to be on the bottom. So 1 over X is the multiplicative in the inverse of the multiplication property. Because this number here, 5, is 5 over 1. So I multiply by its reciprocal, means flip. The reciprocal means flip. So what times 3 over 5 gives me 1? 5 over 3, yeah. Because the 5s cancel, the 3s cancel, you get 1. It's called the reciprocal. It's the flip of the number. What times -4 over 7 gives me 1?
7. -7 is
Very good. -7 over 4. Because we have to get rid of the negative, so we need a negative times negative is a positive. The 7s cancel, the 4s cancel, so we have 1. So those are all the properties of addition and subtraction. Notice that what two operations are missing? Multiplication is also included in the closure property. The closure property of multiplication. X times Y equals Z. A unique number in the same system as X and Y. What does that mean? X times Y equals Z. What does that mean? In the same number system as X and Y. If X and Y are both natural numbers, and then multiply, so natural numbers like 3 and 5. 3 times 5 is 15. Is 15 a natural number? Yes.
Yes.
Or if they're in the whole numbers, 0 times 2 equals 0. Is 0 in the whole numbers? Yeah, it starts with 0. So that's what it means for the closure property. If I multiply two numbers in any system, the answer is going to be in the same system. Whole numbers, integers, decimals. If I have two decimals and I multiply them, I get in the decimals. Section 8 deals with simplifying equations or expressions. What's the difference between expression and equation? Very good. Equations have equal signs. We're solving for a letter, a variable, and expressions are just simplifying. We're just combining like terms. Which expression is simplified form of negative 6x minus 3? I'm thinking about changing all the tests to being in the testing center from here on out. Because yeah, I don't want people to take advantage of me. Those students who are serious about learning are going to learn. Those students who are serious about failing, goodbye. No, you sure? Let's see. 11.8. Number 1. 6x minus 3. Remember, it has parentheses. Can we do anything inside the parentheses? So how do we get rid of the parentheses? What do we have to do? Distribute. Distribute what? Negative. So this actually is -1. If there's better trying to move. That's not good. That's not good.